In this video, we're going to do exactly what we did yesterday, but we're going to interpret the rate of change. So we're going to decide what it means, and we're going to even answer some questions and analyze the graph that we have pictured. This is page 48 in our notes, page 48, and these notes are front and back, so we'll call that 48F for front. This graph is all about Sam taking a trip to New York, and the x-axis looks like we're talking about hours, and the y-axis is being measured in miles. So he's taking a trip to New York. Part A is asking us, in miles per hour, what is the constant speed Sam's car is traveling? Constant speed is just another way to say slope, or rate of change, which is all represented by the letter M. Now this is a graph, so we do have a new first step. That new first step, remember, is to write scale in really large letters. My up and down axis, the y-axis, the very first line is 20, so my vertical scale is 20. The horizontal scale, the very first line actually doesn't have a number. So starting at 0, I search until I find a number. The first number we see is 1. Now we have 1 being split up into 2 spaces. So 1 divided by 2 will give us our scale of 0.5. Now that we found the scale, we can find the rise over the run. So positive or negative, rise over run. Yeah, okay. They've given us all the perfect points on the line because they are so awesome and nice to us. I can use any 2 I want. I'm going to use these last 2 perfect points to draw my triangle. The rise is 1, 2, 3. But we're rising and each line going up is worth 20. So this is really talking about 3 20s. So we'll multiply 3 times 20. Divided by the run is 1, 2. But each line going side to side is only worth a half. So I'm going to multiply that 2 by 0.5, the scale going side to side. 3 times 20 is 60. 2 times 0.5 is 1. So our slope is 60 over 1, and since our pencils point up, it is positive. So positive 60 over 1 is the same thing as positive 60. And they're saying miles per hour because our y value would be the rise is in miles, it's measured in miles, and the run is measured in hours, so 60 miles per 1 hour. The second question is asking us how long it will take Sam to travel 180 miles. Miles is being measured on the y-axis. So I'm going to find 180 on the y-axis. There's 180 on the y-axis. Now the point that has a y value of 180 is right here. I want to know how long it took to get to 180, which means I want to know how many hours that was. So I want the x value of that point, which is 3. And that's being measured in hours. So it took Sam 3 hours to drive 180 miles. Okay. The last question says about how many miles can Sam travel in 1 hour and 15 minutes. I just want to point out that 1.5 hours, or 1.5 hours, is equal to 1 hour and 30 minutes. This is 1 Since my horizontal scale is 0.5, then this line is 1.5. 1 hour and 15 minutes is obviously bigger than an hour, but it's also smaller than 1.5 hours. It's actually right in the middle. So here's the x value in question. 1 hour and 15 minutes was a time. I want to know about the y value, how many miles. So I need the point on this line that has that x value. So I'm just going to drag this point up until I hit the line, which is right here. Now I'm going to cross over to the y-axis to see where we fall over there, or what the y value is. Now the y value looks like it's pretty in the middle between 60 and 80, so we'll just go ahead and call that 70. And that's being measured in miles. Okay. Now that was all about Sam's trip. Now let's take a look at the second question. What is, so here's my graph. The vertical axis is labeled in number of words typed, and the horizontal axis is labeled in time in seconds. So we're talking about somebody typing. And our question is, what is the constant speed of the person typing? We know from the problem before this that when we see the constant speed, that means really rate of change. Rate of change. Or slope, which is all represented by the letter M. Okay, since this is a graph, we have a new first step. Our new first step is to write the word scale, and then we need to find the vertical scale and the horizontal scale. The vertical scale, look at the very first line, there's not a number there, so I need to start at the 0 and then find my first number. Circle all of the things being used there. My first number is 10, and it's being divided into two parts. 10 divided by 2 is 5, so my up and down scale is 5. Now my horizontal scale, find the very first line, is also 5. Okay, now that I have my scale, I'm ready to do positive or negative, rise, over, run. Pencils to the right, on the slant, pencil points up, so this is positive. I need 2 perfect points before I can find rise and run. They've given me a perfect point at the origin, and I see another one located at 30, 20. 30 x value, 20 y value, 30, 20. I'm going to use this triangle. My rise is 1, 2, 3, 4, but that's really talking about 4 5s, so that's 4 times 5. My run is 1, 2, 3, 4, 5, 6, but that's really 6 5s, so I have to multiply that by 5. Now, 4 times 5 is 20. 6 times 5 is 30. When you reduce the fraction 20 over 30, you get 2 over 3. And this was positive. So the slope is 2/3. You would divide the top and the bottom by 10. Or hit math, enter, enter on your calculator. Okay. After 30 seconds, I'm looking at the second question. After 30 seconds, what is the number of words typed? So they're asking us about something on the x-axis after 30 seconds. Yes, after 30 seconds. So here's seconds. There's the number 30. So I want to know how many words are typed. That means I want to know the y value for the point on this line has the x value of 30. To find the point on this line that has an x value of 30, I'm just going to follow that line that represents 30 all the way up until I hit the line on my graph. That's right here. The number of words being represented there is on the y-axis, which is 20. So after 30 seconds, there are 20 words typed. The next question says, how long does it take to type 30 words? So they're telling us that 30 words have been typed. Words is found on the y-axis, so we're going to find 30 on the y-axis, which is right here. I want to find how long it takes, so I want the time in seconds. I want the x value of whatever has a y value of 30 on this line. So I'm going to follow the line representing 30 for my y-axis until I hit the line on the graph right here. And its x value is 45. So after 45 seconds, we've typed 30 words, where it took us 45 seconds to type 30 words. The last question is asking us what the slope of the line represents. 2 is my rise. Rise represents words. So this is 2 words typed. And the bottom is 3, which represents the run, which is the x-axis, and seconds. So 3 seconds. The slope represents 2 words typed in 3 seconds. Okay. And now we will flip over to the back. So we should label this page 48B for back. This graph has an x-axis of seconds and a y-axis of a water level. The situation kind of being described says that our bathtub has 4.5 inches of water when we start to drain it. The first question asks us what the rate of the tub is when it's draining. At what rate? That just means slope, which is represented with the letter M. This is a graph, so I do have to use positive or negative. Oops, sorry. I do have to use my new first step, which is scale. I have to write the word scale. I have to find a vertical scale. The vertical scale, there's no number there, so I find my very first number, which is 1. 1 is being split into 2 spaces, so 1 divided by 2, which is 0.5. So my vertical scale is 0.5. My horizontal scale, look at the very first line, which is 1. So my horizontal scale is 1. Now that I have my scale, I can say positive or negative, rise over run. So this is going down from left to right, so I'm using negative. I'm going to put the negative sign underneath where I'm going to write my answer so I don't forget it. Rise over run. So I need some perfect points. Let's go ahead and just label all of the perfect points. There's one there. There's one here. There's one here. 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 And here even. Okay, and I'm going to use this one and this one. Now my rise is 1. But that's really only a half, so I multiply that by 0.5 over my run is 1, 2. That's talking about 2 ones, so I multiply that by 1. The numerator is 1 times 0.5, which is 0.5. And the denominator is 2 times 1, which is 2. When you cut 1/2 into 2 equal parts, it gets even smaller. It actually becomes 1/4. You could also type that in on your calculator, 0.5 divided by 2, and then hit math, enter, enter. You actually find out that it's 1/4. And remember, this is negative, so this is negative 1/4. It makes sense that this is negative because the tub is draining, which means it's getting smaller. Letter B has 2 parts to the question, actually. Letter B first asks us, how much water is in the tub after 6 seconds? So they're telling me about seconds, and they told me 6 seconds to be exact. 6 seconds, and I want to know how much water is left. So I want to know the y value when x is 6. So I'm going to draw a line until I hit the line on my graph, which is right here. And I need to know the y value that corresponds with that, which is 3. So there are 3 inches left over in the tub. The second part of this question says, how much water was drained? Well, if we started with 4.5, you can see that here. We started with 4.5. And we only have 3 left. If I subtract 3 from 4.5, I'll find the difference, which will tell me the amount of water that was drained. Well, 4.5 minus 3 is 1.5, so 1.5 inches were drained. Now the last question says, how many seconds will it take to empty the tub? To empty the tub would mean I need the tub to have 0 inches. Which means I'm looking at my y-axis and I need 0 on my y-axis. That's this line here, and I'm going to just draw until I hit the line on my graph, which is never so far. The good news is I can find out how I go from one point to the next and just keep doing that until I hit 0. I'm actually going to get some extra paper to put behind this, just in case I run out of room. Okay. So from one point to the next, we're going down once and to the right twice. So we're going to keep that pattern, down 1 to the right 2 times, down 1 to the right 2 times, down 1 and to the right twice, until we get to 0, down 1 to the right twice, until we get to this line 0. I'm officially at the end of what they've given me, so I'm going down 1 again and over 2 times. Now this was 10, so that means this is 11 and this is 12. 11 and 12. This is where I'm at, which is still not 0. So I need to go down, from here, down 1 and over twice again. That was 12, so this is 13 and 14. And now I'm on this line, which is still not 0. So I'm going down 1 again and to the right twice. That was 14, so this is 15 and 16. That's where we are right now, which is still not 0. I still have to go down 1 more line. But that's okay, we'll go down 1 more line, which means we also go to the right 2 times. That was 16, so this is 17 and 18. Okay. Which means it took us 18 seconds to completely drain the tub. In some classes, I might have gone over part of the last example on this page. I do not like this graph. It's hard for me to see which points are perfect and which ones are not. So I'm just not going to bother looking at that anymore. And I will change those notes for next year, hopefully, if I remember. So, as always, if you have any questions, please reach out to me via Schoology message or drop a comment on this video, and I will get back to you as soon as I can.